Hello, and thanks very much for inviting me to this event. I'm Dr. David Schimel, the chairman of the board of Intelligent and a scientist for NASA's Jet Propulsion Lab, and a longtime researcher and actor in the climate world. I was involved with the very first intergovernmental panel on climate change assessment. I was a convening lead author for the second, the one that led up to the Kyoto agreements, and I've been an active researcher primarily on the global carbon cycle for over 30 years. I'm coming to you representing both a perspective from a long career in climate science and a more recent career in climate finance and in the world of climate business. I'd like to talk today about climate change from both a physical risk point of view, from an innovation and technology point of view, and I like to think of where we are at the intersection of climate science, the response of the world and the world's economy to climate change, and mitigation of climate change as a case of two wrongs. And let me explain to you what I mean. I'll talk first about the first wrong. For decades, climate scientists have been trying to project the future of the climate system using climate models, analogies from the past, and other ways of trying to understand the future. And in general, these models have been quite accurate in projecting the response of global mean temperature to changes in greenhouse gases, primarily carbon dioxide, but also methane, nitrous oxide, and other gases that are produced both naturally and from human activities. In general, I would say those projections have been relatively conservative. Scientists have not wanted to be alarmist, nor have they wanted to be overly conservative. And again, when we compare projections from as far back as the 1970s to the present, they've done a reasonably good job of predicting either what has actually happened or looking at it in another way, the response of global mean temperature to increasing greenhouse gas concentrations. Sometimes the rate of increase in greenhouse gas concentrations was in error. Even given that, when correcting for that, one can see that the response of temperature was about right. So what do I mean by saying the first wrong? Well, the first wrong is that climate change doesn't manifest to our perception as a smooth, even change in global mean temperature. Global mean temperature is almost an imaginary concept. And climate models are not intended to, nor are they particularly good in predicting what we might call the weather, the extremes that have the largest impacts on our day-to-day life. Those extremes include drought, they include high temperature exceedance events, heat waves, they include severe storms, tornadoes, hurricanes, tropical cyclones, with accompanying, in many cases, storm surge, accentuated by one of the other main consequences of climate change, which is sea level rise. And it's through changes to the intensity and frequency of these types of events that the primary impacts of climate change on day-to-day life, the economy, and our infrastructure occur. Climate models are getting better at predicting these sorts of extremes, either directly or through indirect means, but they're not intended to predict very fine-scale events far into the future, and they don't. So we have to make inferences about how extremes will change in other manners. In addition, global mean temperature is, again, it's an artificial concept. The temperature of the world varies greatly from north to south, from the poles to the equator, and it varies greatly over the continents as a result of distance from the from the oceans, the arrangement of the continents, the influence of mountains. And as a result, climate change manifests itself differently in the different weather regimes of the planet. It manifests differently at high latitudes, where it leads to the retreat of glaciers and sea ice. And it differs greatly in the major climate regimes of the world. For example, in the monsoon regions, we see climate change manifesting as a change in the timing and intensity of the monsoon. In Africa and South America, it manifests as a change in the duration or the dryness of the dry season relative to the wet season. So we see a great deal of geographic variability, and the impacts depend on the nature of the climate change. Do the wet seasons get wetter? Do the dry seasons get drier? Or do the wet seasons get drier? For example, in California, we've seen a characteristic decline in the amount of rainfall during California's typical Mediterranean winter wet period. That is, the wet period gets drier. In other areas, for example, South America, we see the duration of the dry season getting longer. So what I'm calling a wrong isn't really wrong. It really refers more to an increase in our understanding. But what we see is climate change manifesting very locally and largely through the frequency and intensity of the intense events that have a major impact on infrastructure. So what's the second wrong? The second wrong has to do with the rate of technology to mitigate the emissions of greenhouse gases into the atmosphere. Again, scientists, economists have projected for many decades the rate of improvement in the efficiency of renewables, declines in the cost of renewables, and they've been wildly off, very conservative. Projections of the rate of increase and the decline in cost, for example, of solar energy have been off for factors of 4 to 10. That is, it's a quarter to a tenth what was projected by many integrated assessment models and by the International Energy Agency. So, and this is very hopeful, many of the technologies that allow us to mitigate greenhouse gases are becoming accessible and affordable much more rapidly than had been projected 5, 10, or 15 years ago. And this impression is very much still in people's minds that mitigation is expensive. But in many cases, economists assumed that damages would be managed, if you will, by the invisible hand of the market, that agriculture, infrastructure would adapt in a near optimal way to a changing climate. And that may be true on some time scale, but the unpredictability, the inhomogeneity, and the event nature of climate change's impacts make it very, very hard to adapt to. Agricultural drought can only be adapted to some extent. Extreme wildfire behavior can only be mitigated to some extent. Sea level rise is extremely costly to respond to, and the impacts of sea level rise enhanced events are very, very expensive. So adapting to climate change is more costly than we expected. The impacts are more severe in many ways than we had anticipated, and the financial consequences quite severe, already amounting to globally meaningful numbers, particularly when amplified by regular recurring events like the El Nino cycle. But on the hopeful side, the cost of key technologies for reducing greenhouse gases is becoming more and more available, more and more accessible, more rapidly than had been anticipated in previous decades. And many people still have in their heads this idea that mitigating climate change is expensive, but responding to climate change is relatively inexpensive. That is, adaptation is inexpensive. What's turning out to be the case is that it's actually the opposite. Mitigation is becoming more and more affordable, and adaptation is becoming more and more expensive. And so avoiding the worst consequences of climate change, restricting the growth of greenhouse gases in the atmosphere to levels that are consistent with what we refer to as a safe operating space for humanity, is both affordable and a good investment. So what does this mean from a business cycle point of view? What it means is that the key responses are very much a function of private sector investment to promote innovation, to more rapidly develop appropriate technologies for mitigation, to adapt technologies or develop new technologies that allow us to respond in a cost-effective manner to the impacts of climate change. In addition to that, of course, and I think most people understand this, moving from a fossil-based economy to a renewables-based economy and a high-efficiency economy requires infrastructure, charging stations for electric vehicles, smart grid to allow more variability in the availability of energy, and more storage technologies, both to buffer the variability of renewables, and storage technology to enable disconnected or infrequently connected devices, battery-powered devices of all kinds. And so this is an opportunity which can be, I would say, encouraged and enhanced, enabled by government regulation, but really it requires what the private sector is best at, which is to say investment in infrastructure and investment in innovation. A real opportunity to avoid the worst impacts of climate change and to create wealth as a result of moving to a new economy based on renewables, advanced technology, and optimization, rather than enduring or sacrificing for a reduced availability of energy and energy-enabled opportunities into the future. There's one final point that I want to end on, which is that the world has set a goal of a 1.5 degree warmer world, a world which on a regional basis will be reaching perhaps during this El Nino cycle. And we think of 1.5 to perhaps 2.5 degrees as the safe operating space for humanity. It's been called that in the scientific and popular literature. But we're not quite at 1.5 in most of the world, and we will reach 1.5 either very soon, possibly on a temporary basis, as the climate varies from one year to the next in the very near future. But 1.5 degrees is 1.5 degrees warmer than levels of many decades ago. And we're already living in a world where we see significant impacts from climate change through drought, through extreme weather events, through high temperature events, heat waves, and through sea level rise. And a 1.5 degree world, a bit warmer than the world that we're in now, is going to be a world with a much more challenging climate than 1.5 degrees ago. And that means that there's a huge opportunity for both mitigating the even more severe impacts of climate change associated with 2.5, and the more unthinkable levels that we could achieve if we use fossil fuel in a continuing and ongoing business as usual way. It's also a world in which there are huge business opportunities to enable communities, companies, governments to avoid the worst consequences of the kind of climate change we expect at 1.5 degrees, which is like today, but perhaps a bit more so, and avoid the worst consequences of triggering the so-called tipping points in the climate system, where we move very rapidly to a much, much warmer climate. My message to the world of business is that this is a tremendous opportunity for the private sector to do what it's best, to identify the most efficient and the most profitable ways of mitigating emissions, and also to identify the most efficient and economic ways of adapting to the climate change that we're committed to at 1.5 or 2 degrees. And in my role in the business world, I thought about, as a scientist, very much where I could make my biggest contribution. And I'm not an engineer, so I didn't adopt a particular technology, but I am a modeler and an analyst. And I'm very excited about the opportunities to develop and deploy technology to avoid, if you will, market failure as a result of incorrect market signals, and help the business world understand where the greatest opportunities were to find opportunities for profit, for wealth creation, that optimally minimize the impact of future greenhouse gases and create opportunities for reducing climate transition risk, whether that be a physical risk or a regulatory risk. And I think that a key part of the climate finance, climate business world or ecosystem are going to be climate information businesses that look into the future in a variety of creative ways to identify those opportunities for most rapidly moving away from fossil fuels and reducing the physical risk and exposure of businesses, communities, and citizens. So that's where I'd like to wrap up this brief presentation. I'm very excited to speak to this group, and I look forward to an interactive question and answer section. Thank you very much.